Hello, this is Professor Kuehn, and welcome back to my lectures on electricity, magnetism, and light. When reading ancient and medieval and even early modern thinkers like Isaac Newton, it really becomes apparent quite quickly that they are coming from a very different place conceptually than we are in 2020. This is very evident in particular in Newton. We've been looking at Newton's book, Optiks. At times, you feel like you're reading a modern geometry or science textbook, and other times you really feel like you're reading the work of a philosopher or a theologian or perhaps even an alchemist in some sections. So take, for instance, his query number 28 in his book Optiks. He there argues that light, this is what we've been talking about for the past week or so, that light behaves like a particle. And moreover, he kind of spends a lot of time talking about Christian Huygens' ideas that light is actually a wave passing through this ether that fills all of space. He says that Huygens' theory, the wave theory of light, is not a correct theory of light, and at the bottom of page 216 in the text, he mentions that it's a false theory because there isn't any ether. Because you might recall that he talked about how ether would exert a drag on the planets, for example, and we don't see that, and so there's probably no such thing as ether. He goes on the top of page 217, I'm doing a little bit of review here, he talks about how forces like gravity, some people had thought that they were some material substance that's pushing or pulling on something. In fact, Newton entertained that idea himself. But he says that they may not, in fact, have a material cause at all, as many philosophers thought. After all, gravity, if you think about it, is very peculiar. It acts over empty space. So Newton argued that the sun is pulling on the earth, and there's nothing connecting them. And that's really weird. I mean, that almost sounds like magic if you think about it carefully. There's no ropes, nothing connecting them, and yet they pull on each other across empty space. So he says there's these certain puzzles that come up in studying nature. And when one studies these sorts of puzzles and asks what's the cause of this, and if you find the cause, and what's the cause of that, and you can kind of go back and think backwards, as it were, not necessarily in time, but in terms of the justification or the cause of things, a logical reason behind things, until one arrives at a final cause, which he says is God himself. So if you look at page 217, about the middle of the page, he says these things being rightly dispatched, he just kind of talked about a number of these puzzles, he says these things being rightly dispatched, does it not appear from phenomena that there is a being, incorporeal, living, intelligent, omnipresent, who in infinite space, as it were, in his sensory, sees the things themselves intimately and thoroughly perceives them and comprehends them wholly by their immediate presence to himself. So in other words, God doesn't have any eyes or nose or mouth, but he can still perceive all of creation. And how is this done? Well, he says it is done immediately. So this, by the way, is on page 217. I've just jumped ahead in the text of that. I'll highlight it for you. God doesn't have any eyes or nose or mouth, and yet he perceives these things immediately. So how does this happen? So this is going to be a little bit of a digression on how Newton, I think, is thinking about this. So ask yourself the question, how would you think about an object like a red ball? Okay, so in your mind right now you're perceiving, or you're thinking about conceptualizing a red ball. Well, according to the modern way of thinking about this, what happens, the reason you can think about a red ball is because at some point you saw a red ball. And the light, but you didn't actually see the red ball. You saw light that is coming from the red ball. It's striking your eyes and causing this sensation in your eyes, this physical process in your eye, which travels down your optic nerve, and somehow this forms an image of a red ball in your brain. And this might sound plausible to many modern thinkers, but it's important to point out that the image of the red ball in your brain is a very different kind of thing than the neurological signals going through your optic nerve, or the light waves or particles that are striking your eyes. They're just fundamentally different things. There's a big difference between light of a certain wavelength, according to the wave theory, or light particles of a certain size, according to Newton, and the concept of a red ball. And more generally, the qualities that we experience, qualities like color or sound, tones, taste and smell, they don't really have a clear connection to the physical processes that purportedly produce them. They're qualitatively of a different kind than those physical processes. Our perception of red is not the same as a 632 nanometer length wave. Okay, so I'm bringing up there's this sort of puzzle. This is a philosophical problem. How do we form these images in our mind based on these purportedly purely physical processes? Well, the way that the medievals thought about it was a little bit different. They said that all objects, all things in nature, are comprised of two components, matter and form. And we talked about this a little bit earlier in the semester, but let me remind you a little bit about this. So if you have something like a rubber ball, I'll write this down, make a little table. If you have a rubber ball, well, it's comprised of matter. What kind of matter? Well, in this case, it would just be rubber. And the form that it has would be the form of a ball. Okay, so it's made of rubber and it's a ball. Of course, rubber could take on different forms, but the form is a ball. If you think about an oak tree, I'm using some of my stock examples that I've used before. Well, what's the matter out of which it's comprised? Well, primarily wood. Of course, there's water and some other stuff in there, but wood. And then it's the form of an oak tree. That's what it is. Okay, and you could take an animal like a squirrel. Okay, so a squirrel, its matter is, well, it's got a body, a physical body made of various elements and things. But then it has a form. What's the form of it? Well, it's got an animal form, the form of a squirrel. And you might even say, and this is a medieval way of thinking about this, it has an animal soul, some kind of principle or soul that informs its body, that makes it alive. Okay, and likewise, man, human beings, they have a body, and they also have a form, and in that case, it's a rational soul. It's a soul like an animal soul, but it's a different kind of soul. It's a rational soul. Okay? So all things are comprised of matter and form. It's no more mysterious that the body has a rational soul in comprising man than a ball informs rubber to make a rubber ball, or an oak tree is the form that wood takes to make an oak tree. So these are all different kinds of form. The rational soul would be called the form of man. Okay? Now, what does this have to do with the concepts that we're talking about here and how it's distinct from the modern way of thinking about conceptualizing a red ball? So our minds, the mind of a human being, the rational soul, and the mind of a human being is a bit different because our minds can take on the forms of other things without becoming that thing. So our mind, according to this medieval way of thinking, our minds, that is human minds, can take on the form or forms of other things without becoming that thing. Without becoming that thing. So normally, if rubber takes on the form of a ball, it becomes a rubber ball, right? But our minds are unique in that we can somehow grasp the form or take on the form of a rubber ball without becoming a rubber ball, and that is when we are conceptualizing a rubber ball. So our mind, in other words, our mind can grasp the form of a rubber ball without becoming a rubber ball. Okay, and this is the unique power of us, and this is how we might say we are informed. We're informed, we're thinking about a rubber ball, and that form is somehow existing in our mind. This form is present in our minds, and that is how we contemplate that thing. So that's a medieval way of thinking about conceptualizing things. So why am I bringing this up? Well, this gives a little bit of insight into how Newton is talking about this. He says he's here suggesting that God can perceive things by their immediate presence to himself. So he doesn't have an eye or a nose or a mouth, and yet he understands and knows, he's omniscient, he knows all things because the forms of all these things exist in his mind in a similar or analogous kind of way as we think about things. Their form is in our mind. So this is maybe just a little bit of a digression on how Newton is adopting some of these medieval kinds of categories, and he's usually thought of as a modern thinker, but like I said, he is this kind of transitional figure, so it's very interesting to think about that. Okay, let's move on. Let's finish up our discussion of Newton's optics. And on page 217, his query 29, he asks once again the rhetorical question. He says, are not the rays of light very small bodies emitted from shining substances? Okay, so there you have it. He's asking the rhetorical question. His answer is yes. When a shining substance shines, it emits these tiny bodies, and these shoot out and they hit your eyes, and then that's how you perceive that kind of thing. Okay, and so then he goes on to say, if you look at the next page, he explains how he's going to try to explain how this particle theory of light can account for various kinds of phenomena that exist in nature. So things like reflection of light from a mirror. Well, if light consists of these tiny particles and they strike a mirror, they bounce off the mirror, kind of like a ball bouncing off a wall. So there's not really a mystery about how thinking of light as particles would be inconsistent with the law of reflection. In fact, Newton's arguing that it is very consistent with the law of reflection. But then he goes on to, he tries to approach this issue of refraction. So how does refraction work? Well, he says that when you have, he says, a pellucid substance, or a substance through which light can travel, but it bends in going through it, what happens there? Well, these particles of light, he says, are, when they come near the substance, there's an attractive or repulsive force between the components of that material, the atoms of that material, and the light particles. And that force changes the trajectory of the light particles, and that's what causes them to bend when they're entering that substance. Okay? And if you look, I guess this was on, I don't know if this was on page 218 or 217, he talks about how some evidence of this also is if you take a piece of glass and there's light going through glass, we've heard about total internal reflection. That is where you have, if you have right here, you have glass, and you have air, and you have some light particles, he says, coming in like this, they will bounce off and continue into the glass. It's total internal reflection, and that's because of the attraction that glass exerts on the light particles that prevent them from going out into air. But he says, if you were to take some layer of honey or some other kind of substance and smear it on top of this, like honey, then it reduces the attraction into the glass because maybe honey is trying to attract the particles as well, and so some of the particles are able to escape. So that's a way of mitigating or getting rid of this total internal reflection. Notice here, if you find this a little bit implausible, he's not providing any mathematically rigorous demonstration of this. He's simply arguing that we know that particles attract other particles, and this is why he's so interested in these kind of chemical reactions he talks about at a different point in the chapter. He says we know these atoms combine and uncombine in order to form various elements, so it wouldn't be surprising at all if light particles were attracted or repelled from the atoms that make up substances. Okay, and then he also talks about the phenomenon of dispersion. So he doesn't use that term, but let me just make a sketch right here. What is he talking about? So if you have a prism made of glass, we talked about how light in entering glass, that's a terrible prism, let me draw it again. Okay, so if you have a prism that's made of glass and you shoot a ray of light at this prism, we talked about how the light bends in going into the prism. Let me draw that again. This ray of light, it bends in going into the prism, but he mentions here that different colors of light get bent by different amounts. So the red light, so the light coming in, if it's white light, it's actually comprised of all different colors. The red light gets bent some, but not much. The orange gets bent more, red, orange, and then yellow gets bent even more. Green gets bent even more, and blue gets bent even more. This isn't meant to be mathematically correct. It just gives you the idea that these red particles get bent the least and the violet particles get bent the most. How does his particle theory of light account for this? Well, he says the various particles of light have different masses. And because the red particle is most massive, it has the most inertia. And so as a result, these forces with which the glass is pulling on it to change its trajectory are least efficient in changing its trajectory, so it goes closest to a straight line. And he says that these violet particles, in fact, are very tiny particles, and that's why the force that the glass exerts on them is most pronounced, and it changes their trajectory by a lot. So this is the kind of way that he's going to say his particle theory of light can account for these various kinds of phenomena. And then finally on page 219, I'd just like to say one more thing about this, page 219. He's talking about, I guess at the bottom of 218 and the top of 219, he's talking about all different kinds of transmutations in nature. So he says, are not, this is query 30, are not gross or large bodies and light convertible into one another? And may not bodies receive much of their activity from the particles of light which enter their composition? So he's saying here, how is light produced? Well, they're actually generated from other atoms that transmute into light particles. So if you heat something up, some of the atoms of that particle become light particles and shoot out. Now, why would he think this? Well, he says there's all kinds of examples of transmutations in nature. So he says the changing of bodies into light and light into bodies is very conformable to the course of nature, which seems delighted with transmutations. Water, which is a very fluid, tasteless salt, she changes by heat into vapor, which is a sort of air, and by cold into ice, which is a hard, pellucid, brittle, fusible stone. And this stone returns to water by heat, and vapor returns into water by cold. He goes on to say that earth, by heat, becomes fire, and by cold returns into earth. Dense bodies by fermentation rarefy into several sorts of air, and this air by fermentation, and sometimes without it, returns into dense bodies. Mercury appears sometimes in the form of a fluid metal, sometimes in the form of a corrosive, pellucid salt, and so on and so forth. And he goes on to say, all birds, beasts, and fishes, insects, trees, and other vegetables, with their several parts, grow out of water and watery tinctures and salts, and by putrefaction return again into watery substances. and water standing a few days in open air yields a tincture, which, like that of malt, by standing longer, yields a sediment and a spirit. But before putrefaction is fit nourishment for animals and vegetables. And among such various and strange transmutations, why may not nature change bodies into light and light into bodies? So he has this view of nature always undergoing these transformations. I mean, we can debate how these transformations happen, but the fact is, things change, right? And so he's saying it would be sensible if light particles could be generated out of these other substances. Okay, so we're going to put Newton behind us, and we're now going to go on to the work of Thomas Young. We're going to move ahead about, 150 years or so to about 1809, and look at, over almost 200 years, to look at his lectures on light.